Hi, Anand. Hi, Kate. I see your name here.
We've hit a complicating factor, Anand. Can you send me a unique name? Because if I log in with the link, I'm Kate as well, which
Hello,
might add a
Kate.
little
I
complication.
recognize Eric Shook's voice with Kate's double names for Kate. And Anand, you're muted.
Oh, sorry. Eric, go ahead and rename yourself. I just gave you that permission.
Okay, thank you. Or maybe I'll stay Kate and we'll see what happens. Have a little fun with everyone.
So Eric, will you be managing some of the Q&A things
Yeah.
today? Great.
I think there is also a Q&A box where, like, if chat is getting like really complicated with so many people typing, we have a Q&A box where people can answer questions or post questions and we can answer it, and it keeps it threaded and knows what is answered and what's not. So if people can use Q&A box, that would be good. Also, we are recording this session. Shortly, I think we will have like some of our people from the cyber infrastructure team join here as well. So if there are people are facing technical issues, we can reach out to them, and we don't need to slow down the rest of the team as well. So
Wonderful. Yeah, I can help manage chat and Q&A. And if there's things that I can answer or can get the answers for people through back channels while Kate's talking, I will do that. And then I'll queue up questions for Kate once she's done so that she can kind of, just for those who joined early, we'll have an introduction, and then Kate is going to walk everyone through the notebooks. We'll have some resources, and then feel free to type in the chat or the Q&A box. I'll help manage some of the questions, and then the ones that I can't answer or get answers for, I'll kind of queue up to ask Kate at the end. So yeah, everyone, as you know, as questions come up, please feel free, type them up. And then at the end, if you're wanting to unmute your microphone, we'll also have some time for Q&A. But yeah, type it in the chat or the Q&A section. And we'll go over this again in a few minutes.
okay, it seems we have multiple avatars of you logging in. So I think you might have shared your link with a few people. So yeah. So yeah, if anyone wants to change, rename themselves, they can do that.
I did. I did not realize it would name them all me. That's an interesting Zoom quirk.
Yeah.
Yeah, I've never seen that before. They must do that for webinar registrations, and then they automatically set that name rather than your default Zoom name, which is I've never seen that before. So I do think that they mess with some stuff that last major update, because I've been in a couple of meetings of people like me who are very regular Zoom users, like many times a day, and like now there's some quirks.
Maybe we'll wait a minute or two. We had over 200 people registered for this, and we capped the registration so that we have a manageable crowd here. And I'm sure we'll get a few more people joining in as time progresses. So yeah, Diana, you would be handling the introductions and stuff, right?
Yeah, yes, I'd be happy to.
Great.
Hi, everyone. My name's Diana Sinton. I'm a senior research fellow with the University Consortium for Geographic Information Science. And I welcome you today to this virtual consulting office session that is hosted by iGuide. iGuide is the Institute for Geospatial Understanding through an integrative discovery environment funded by the National Science Foundation. And we have a regular VCO series. Today, we are excited to be able to have our very own Dr. Kate Vavra-Musser here. Kate has been with iGuide for a while and is most recently has been a postdoc at the University of Minnesota. And Kate is going to be talking today about the way that she's been designing some Jupyter notebooks to be able to use in conjunction with IPUMS data through their API and using the resourcing and computing capabilities of the iGuide platform. So your microphones are going to remain muted during our presentation, please, during Kate's presentation. Please write any questions that occur to you either in the chat or also in the Q&A box, which you can access with the little more ellipsis at the bottom of your screen. And there'll be enough time for questions, and this is being recorded, and we'll post it and have it up on the website so you can share it and consult it later. And we also are going to be assisted by Eric Shook to respond to questions as well. And I'm going to turn it over to you, Kate.
Before Kate, I'm just going to say one 30-second plug. So welcome everyone. My name is Eric Shook from the University of Minnesota. I am going to be watching the chat and Q&A, and I'll try to answer questions if they're kind of within my realm of responsibility. Otherwise, we'll queue them up for Kate to answer at the end. So feel free to type into the chat while she's talking, or use the Q&A button and put your questions there. We'll try to get them answered as quickly as we can. And for those that we can't answer immediately, we'll have available for Kate. I'll also be posting some links as she talks about a few things, just so that you don't have to furiously transcribe anything. So just letting everyone know that. So sorry to jump in and interrupt just for a second, but just to let everyone know that you don't have to quickly take notes or do screenshots or anything like that. We'll get you the information. So, all right. Thank you. Now take it away, Kate. Sorry.
No worries, thank you. Yeah, thanks so much, Diana and Eric, for the introductions. I'm gonna just for this session, so I'll quickly go over what the R Spatial Notebooks project is, and then we'll do a little bit of demonstration. And today, the demonstration we'll be focusing on is using the IPUMS R package along with the IPUMS API to extract IPUMS USA data from the IPUMS repository directly into your R workstation, R workbooks, and then doing a little bit of EDA. So A lot of the notebooks within the project that I'm working on are spatially oriented. This one today is a little bit more focused on tabular data. So just IPUMS USA includes a lot of census data, and I'll talk more about what that is. But this the tabular data extraction and management workflow is also an important part of spatial data workflows, since most of the time we're also working with some kind of tabular data as well. So hopefully this will be useful, and I hope that it's interesting. And of course, as Eric mentioned, all the links to everything will be available for you, and those notebooks that I go over today, as well as the other notebooks in the project, are available for you to use for everyone. And I'm going to put, oh, Eric just beat me to it. Eric, I was literally just pasting that link into the chat. So yeah, Eric included my link tree. The first couple links on there are specifically if you want to do a code along today, a couple things for you to do, and then some more information on the project and other things. So everything you need to know hopefully is in that link tree. Okay, so let me share my screen. Make sure I've got the right screen. I have a lot of screens open. Okay, so as Anna and Eric mentioned, I was most recently a postdoc at the University of Minnesota. I previously received my PhD from the University of Southern California. And here's a little bit of information for anyone who wants to code along. Again, those links are in the link tree. So if you don't want to kind of try to write down these links, just click the link tree and they're all there. Just a reminder, please don't try to use your Gmail account when you're trying to log into the iGuide platform. Please use a CI login, so please use some kind of institutional login if possible. And just a note to anyone who might be interested in coding along, it looks like we might be running into a little bit of an issue with one of the notebooks, so I'll talk about that, but you should still be able to code along with the other ones. So just this would be a great time if you're interested in doing that, to set up your IPUMS USA account and then get started with logging into the iGuide platform. Okay, so why did we create this project? So if any of you are in social sciences or in research or in data analysis, you'll know that using or developing data analysis workflows involves a lot of different tools, involves a lot of different steps. Sometimes that can make collaboration and reproducibility of those workflows a bit difficult. So what I've tried to do is create a series of notebooks that helps users develop reproducible workflows in kind of a modular series, all in our coding language, which is a fantastic place to if you want to do collaboration and reproducibility, since it is all open source. And this can hopefully streamline your process and streamline the ability to be collaborative with your process when you're developing your analysis workflows. So the project has a lot of different workflows, and I'll show you kind of the landing page for that project in a second. But it focuses a lot on specifically data extraction, data manipulation, some data analysis, and then has a lot of focus on spatial data analysis. So that involves the particularities of working with spatial data in R, as well as spatial analysis tools. If you're used to using a GIS, those tools would be kind of the same as doing spatial tools in a GIS, like buffers or distance calculations or hotspot analysis. All those things can be done in R. And then, of course, lots of mapping tools and mapping skills. This project also focuses a lot on IPUMS data because we have a collaboration with IPUMS for the project, and I'm really excited to just be able to showcase the IPUMS amazing data repository and their API, which makes it really easy to directly extract data right into your analyses. If you are an IPUMS user and you are used to using their web-based data query platform, which is fantastic, this is going to be a new way for you to potentially extract that same data directly into your code or into your coding workspace. And then you can very easily just tweak and modify those extraction queries to be able to reproduce or slightly adjust those data extractions, which is fantastic if you want to do kind of easy little quick adjustments to what you're working on rather than going through the portal and redoing your entire analysis or abstraction specification and then downloading that. Okay, so the R Spatial Notebooks website looks like this, and that R Spatial Notebook, a link to that website is in the link tree in the which is in the chat. So you can see that the way that I've kind of structured it is in this sort of chapter format. And if you get into the notebooks, you'll see that there's kind of, especially if you get deeper into some of the later notebooks, you see that there's kind of like a prerequisite for some of the notebooks or suggested, initial work on previous notebooks if you want to do the particular one you're looking at. So I tried to design it a little bit like a book or like a series of education modules or something. So hopefully you, even if you're starting early on with R, you can start at the beginning and really kind of start to build up both your R skills as well as your skills at finding, extracting data, and working with data. Just going to take a quick look at the okay, so I know there's a couple people who are having issues signing into the iGuide platform, especially people who are asking, what do you do if you don't have an institutional login?
Yeah,
and sending me some
we'll get that
CI.
sorted out, Kate, so you can
Okay.
keep.
Okay, great. I just wanted to make sure that we're okay. Great.
Yep, I'm
Thank you.
chatting with people behind the scenes. So, yep, you just keep
Okay,
going. We'll
okay, good.
I'll help get responses to everyone. So if you're asking questions about login, we'll get you answers in just a second.
I made the mistake really recently, a couple months ago, to get a second monitor, and now I just have too much information. So I can't just have the blinders on with just looking at my on my presentation. I can see the chat too. All right. Okay, so yeah, and the link to just taking a look at the whole project is here. It's also in the link tree. And I have quite a few notebooks that have been released. If you came to my previous talk on January 15th, some of the notebooks that were released there I've unreleased and I'm working on updating them. They'll be re-released soon. And I have additional notebooks in the pipeline. So stay up to date. Feel free to follow me on or sign up for my mailing list. I'll be having more notebooks coming soon. Okay, so today we're going to, so after the introduction, I'm going to do a quick demonstration of a few of the notebooks. We're gonna go through potentially up to 4 notebooks. We'll see if we get to the 4th one. I think we can get through the first 3. Again, you can access all of the notebooks here. These the links that are linked on my website will take you directly to the iGuide platform. So I'm gonna get out of this, and we're gonna go over to what you will probably be seeing here with all the available notebooks. I'm gonna start with this introduction to IPUMS and the IPUMS API. If I open that link, I have it already open here. It takes you to the resource kind of landing page for that particular notebook within the repository of products within the iGuide platform. So the iGuide platform is a place where you can share and use code notebooks, education materials, data sources, lots of different types of materials. And the nice thing about notebooks and data sources is you can directly launch the iGuide platform and use them within iGuide. So I'm going to launch this one by clicking Run This Notebook. And this will be the first one we take a look at. This one does not actually have any code in it. So if you want to just look it on here, it's exactly the same. But if you open these notebooks within the iGuide Jupyter Hub, you'll see that all of the, I'll look at one that actually does have code. All of the code snippets are runnable. So you can run them just in the same way that you would run a Jupyter notebook on your own machine, which is fantastic. And some of you might be asking why we're using Jupyter notebooks for this, and that is the rather than R notebooks, and that's the supported format for the IGUIDE platform. But all of the code that is included in these Jupyter notebooks, the R code is R code, not Python code, and can be run in an R, in a regular R environment like RStudio. Okay, so the first notebook that we're going to go to is this quick intro to IPUMS and the IPUMS API notebook. So as I mentioned, this doesn't have any code. This is just kind of a resource for you to get a little bit of an understanding of what IPUMS is and the IPUMS API. So IPUMS, this integrated public use microdata series, is a repository of multiple different data products that are hosted by ISRD, the Institute for Social Research and Data Innovation at University of Minnesota, and includes both international and US data. The one that we're going to work with today is IPUMS USA. If you're here for my January 15th webinar, we worked with this National Historic Geographic Information data. And these are all links, so if you want to explore what's available, you can link out and take a look. But basically, the one we're going to work with today is includes the decennial census data and American Community Service data. Survey data. So basically United States demographic data. We're also going to be using the IPUMS package. So that's the package. If you want information on it, click here. But that's a package that includes access to the IPUMS API for R, as well as functions for managing the data that is extracted using the IPUMS API. If you want to code along with me and where you want to work with this later, you'll have to go to the IPUMS website, where this is also in the link tree, and set up your IPUMS API account. So you just need to set up an account. It's free, and you will get sent a API key that you can then use for downloading data. And this is a little bit of an overview of the functionality. We're going to be using USA data, which allows you to request and download data. Some of the other data repositories are not available for download through the API. No, I need to know maybe come. See. Okay, so as I mentioned, all of these notebooks are kind of structured in sequence, so you can use these links to go to kind of a suggested next step. But the next one we're going to work on is chapter 3.1, which is IPUMS USA data extraction using IPUMSer. And it might not work quite well within the platform, but I have it loaded up over here. So if you're working through these links, you should be able to just click on that USA data extraction using IPUMSer and get that next notebook. We're going to load that up. I've got 2 instances of Jupyter running. I'm going to close one of them so I don't overwhelm myself. Okay, so we're going to use the IPUMSer package to do some data extraction from the IPUMS USA. As I mentioned, this repository includes ACS and census data, including historical data all the way back to really early censuses in the United States. This is a little bit of background information. If you're not familiar, you can check that out. But we're going to go right into the coding component of this notebook. So in each of these notebooks that includes code, there is a setup section that includes kind of just information on what packages that this particular notebook uses. So one thing that I think is really hopefully useful is sometimes, especially if you're a new R user, it's difficult to understand why a particular package is being loaded and used or what it's being used for. So I try to make that really clear by explaining what packages are being used and specifically what commands from those packages are used in this particular notebook. So there's a little background on that. Then we will load and set up the notebook And this is where I was running into a little bit of issue before. So I think that we're having a little bit of issue with the IPUMS package installation within the IGAD platform. So what I'm going to do is I'm going to run this just on my own machine, which I thought I had already up, but I guess I closed it, of course. Okay, so this is going to be fixed and you'll be able to use this very soon. And the only issue, I believe, is just the IPUMS package needs to be updated in the system. So what I'm just going to do is run this locally. So this is just my local personal version of this exact same notebook. All right, so we'll run our load all these libraries that we need. If you are using this on your own environment, if you're in the IGAD environment, usually you do not have to install them yourself. It should be already installed in the kernel, but if you're running this locally, you can uncomment this and install these particular packages first, but I've already got them installed, so I'm just going to load them. Then I'm going to run this cell to import my API key. And I have my API key just over in a text document on the side over here. And once I enter that, now that's going to be saved for this particular session. All right, so there's a lot of steps that are involved in kind of setting up data extraction with IPUMS. So the first things that I would suggest, especially if this is your first time, you're new to working with the IPUMS package and the IPUMS API, is to take a look at what data is available by using this get sample info command. And I'm going to specify USA to say that I want the information on all the data that is in the USA repo, which is the one we're looking at. So I'm going to store that to this metadata USA object. Take a look. We can see we've got 150 samples. We added a couple actually since I wrote this. But let's take a look at what is in there. So this is just the first 5 in this note in the repository. And you can see kind of it starts with some of the really early ones from 1850 samples from a very old census. So we can tell from this preview that there are a couple of qualities of or characteristics of each of these data sets is that they have a name, which you can kind of consider as like a identification code that you can use that the package will use to reference a particular sample, and a description, which would be kind of like what that sample is. So we're just taking note of what each of these samples in the repository, kind of what their metadata is. So now we're going to filter metadata by criteria. So what I'm going to do is take that object that has all the metadata and that we use to store the metadata, use this filter command, and this is just a command to say I'm going to look for this particular phrase in the description column, so this column. So I want to look for ACS data from 2010. I'm going to filter my metadata objects for all the data sets that have the word 2010 and the word ACS in their description. So we've got these 5 data sets that meet those criteria. And we're just going to take a note of that and say, okay, this is what I'm interested in. Here are my options. I'm going to think a little bit more about what these are, but that we just have that list there. Okay, so oh, and just a note also, if you're not familiar with using the ACS, the Census, United States Census reports ACS data both as single years. So this is just the 2010 ACS. So that was the survey that was collected in 2010, as well as these 5-year summaries. 3 and 5 year summary, sorry. So because we did 2010, it's giving us both the 3-year summary that starts with and ends with 2010, as well as the 5-year summary that starts and ends with 2010. So, okay, so now that we have kind of a list of what data sets are available based on the criteria that we're interested in, gonna kind of select one of those data sets and take a look at what variables are available. I'm just looking quickly at the comments. Elise, does IPUMS have a list of data set names one can look through online or a spreadsheet? Yeah, so you can, okay, so going back to this intro to IPUMS notebook, IPUMS it does have a really great website formatted to look at each of the different categories. So these are the specific repositories, and it's pretty simple to see kind of the groups of data within those. If you want particular like the specific list of all the data sets that are available, I do have a list that is linked in these documents, or sorry, in these notebooks. Here it is. So there's the entire list of data sets available from the IPUMS data repository. Oops, that wasn't the link I was looking for. Oh, here we go. Anne Rogers, thank you so much for posting that because I'm having trouble. I think I accidentally just might have deleted that. So yes, there is a list. Okay, sample descriptions. I think that's it. Yeah, sample descriptions. So this is the USA. Is that the one? Oh, this is okay. That's the description, and shared the sample IDs. So these are linked in the notebooks. I apologize. I think I actually cleared it. But yes, they're all available. It is a little bit convoluted to try and find them, unfortunately. If you look also within, this is the web-based data extraction platform. And you do select samples. It can also give you kind of an overview. This is I think what I would do is the easiest way to kind of get a quick overview of everything that's available from a particular repository. But yeah, it is a little bit convoluted to find information on the codes as well as the variable codes. So I provide hopefully some information on that and finding the information in this document. But yeah, resend the link to the notebook, please. Here is all the notebooks. So I'm working right now in 3.1 IPUMS USA. Okay. All right. So getting back to taking a look at the, sorry, I scrolled way too far. Taking a look at the information or taking a look at the data. So we filtered the metadata. And we're going to set up our data extraction. So we have these options for what we want for this particular exercise. I'm going to choose the 2010 single year ACS, I believe. Yep, 2010 single year SES, which is the USA US 2010A code. So to do that, to set up our data extraction, I use the define extract micro command. Specify the collection using that same code that we used before to specify when we're looking at metadata. So USA, to say I want this from the USA data repository. This is an optional description. You can put anything you want in here. It's just kind of for yourself to remind yourself what whatever extraction is you want to call it. I'm going to specify my samples. I'm just going to do one sample from this particular repository, which is going to be that US 2010A. So that's the single year ACS data set. And I'm going to specify my variables. This is the stuff that I forgot. So for specifying for your data extractions, you do have to specify specifically what variables that you're interested in. And again, for this, I generally use the online data extraction platform. From my experience, it's the best place to be able to find what specific variables are available for your particular data set. So go online and look up the data set and find the variables. If you're asking yourself, this seems convoluted if I have to go to the actual online portal and then look at the information there and update this here. Let me tell you, just hold on a little bit because the real benefit of using the API in R, even if you do have to do some of the initial steps by looking online and getting that information about variables and stuff, the real benefit of using an API and using R is that you're going to be able to really easily adjust and adapt your data abstractions. So once I have this all set up, maybe I'm running analysis, but I say, okay, I want to do this exact same thing, but I want to add one more variable, or I want to do this exact same thing. Maybe I want to add or want to update to this 3-year versus the single year. It's really easy to update this extraction. You can also do batch extractions and run multiple at the same time. And that really streamlines your process and streamlines reproducibility. It's much easier also to share this code definition with another person than the particular definition or than the description of everything from the online portal. Okay, so we're setting up our data extraction. We'll run all this to set everything up. We're going to take a look at review what that data extraction looks like. So everything looks good. We're using our US 2010 sample, which is that single year ACS. Got all the variables we selected. We're ready to go. So we're going to submit our request next using the submit extract function with that definition that we specified earlier. I'm going to run this whole chunk, which is going to run these 4 commands. So it's going to submit the extraction, and then it's going to do this little wait for extracts and status steps. These are both technically optional, but what it does is it kind of like hangs out or hangs your code waiting for that extraction to be ready and checks on it periodically until it's ready to download, and then it downloads it. If you're used to using the web-based platform to do data extractions, you know that it takes a few minutes for that data extraction to come through, and then you get like an email notification about it. So this is the same thing happening here. It's just taking a couple of seconds to do that extraction and then download. So now I've got download information, and that is stored in this object file path that I've sorted as. This is all set. So the things that are what is downloaded is this special object, which includes a GDI data documentation initiative object. So first we need to extract that from the file path using this read IPUMS DDI object. So I'm going to extract the DDI and then use the read IPUMS micro function with the DDI to extract that data. And I'm going to put that into this object called that. And it's working. All right, so that's all set. And that is going to look just like a simple feature object. There we go. Just like a regular data table that you might be used to working with in R, or looks similar to what you might be working with in Excel. This is all the code to append. I Actually, someone asked, does this code depend on a specific version of IPUMSer? I have not personally updated the IPUMSer package recently. I think that it's a relatively new package. I don't think I would worry about that. Technically, yes, but I'm not sure actually. Is there an advantage to using IPUMSer over tidy census? So IPUMSer is going to specifically extract data from the IPUMS repository versus tidy census, which does that for the US Census. It's very similar because the census, the USA component of IPUMSer is a census data that's been slightly modified a little bit by IPUMS to make it a little bit easier to use in some respects. The nice thing about IPUMS is they have harmonized data sets like the census data or ACS data harmonized to a specific census year, which is really useful if you're doing time series data. So it's not going to be massively different. Personally, I think IPUMS is a little bit easier to use than census. However, IPUMS also does have all those other data sources that are not part of tidy census. So if you're interested in any of these international global health data, none of that obviously is in census. So I think that the two using census versus IPUMSer is going to be a little bit different for your different needs. I personally really prefer using IPUMSer when I'm working with census data, but that's personal preference. Tidyverse is also great. Also, I will add that the IPUMSer package is mostly just for extracting IPUMS data from the website. It doesn't do a lot of data analysis and manipulation. And I don't know the tidyverse package well enough to know how far deep it goes into that. Thank you, Eric. Yeah, that I didn't want to say that specifically because I wasn't sure if there was additional or update versions, but I don't think there's been an update that's massive enough to cause issues. So I don't think it's a quite new package.
Yeah, I don't think so. And just for everyone's information, if there's a major API change, which could happen in the future, obviously, I did add a couple of links. One is to Kate's suggestion box, and then the other one is to the IPUMS contact support. And usually by reaching out to one or both of those, you should be able to get at least kind of answers to questions, because for the most part, IPUMS is really good about trying to help go from making sure that things are backwards compatible. So if the API is starting to break, they can suggest, oh, just change this to that, and then you should be able to keep running.
Thank you, Eric. Yeah. That's a great answer. I'm just taking a look while Eric was chatting about some of the other questions here. So does the notebook allow integration with SQL database or any advantage of Jupyter Notebook in terms of performance? You can use R. So the Jupyter Notebook use is really just a platform for using R. You can use the same code in any other space in RStudio or anything like that. And yes, you can integrate SQL databases with R. That's not something I want to talk about today, but yes, you can do that. And you can also query other warehouses using R. Whether it's a performance benefit of Jupyter Notebook, I'm not sure. I'm not sure how to answer that really. How do I set the file path? Sharon, that's going to be the next step. We're going to talk about how to save it and CSV. Does the IPUMSer package allow for census? Yes, Evan. So, yes, someone is answering that. IPUMS NHGIS does have GIS files. If you want to get more information, there is a recording of my January 15th talk where I do a very similar workflow that I'm doing today, except I use the NHGIS data. So it has the tabular data plus GIS files. So if you're interested in doing GIS, which is The GIS within IPUMS is very similar. It's based on the Tigerline data. That is exactly what you'll do if you're doing this extraction with NHGIS. So go check out that webinar recording and also the NHGIS specific data extraction notebook. Visualization data. I said the problem. Okay. Yeah. Okay. Great. So where were we? Okay, so we downloaded our data. Here is the tabular data set. This is the first 5 columns or 5 rows. So you can see we have the ACS year, sample identification, all this stuff, as well as those variables that we specified, right? So sex, age, race, etc. For this ACS data set. And the ACS data set is on individuals. So these are all individual level data. So we have information on their race, age, etc. We're going to take a look at just the column names. Look again. Here's everything in there. And I'll just give a little description of all of the columns for this particular extraction, just so we have it, and also because we're going to be using the same data file in later notebooks. All right, so the last thing we're going to do, well, before we save it, what I'm going to do is I'm going to subset this data set specifically to just the state of Michigan. I choose Michigan because that's where I'm from originally. And I just do that just so it's a little easier to work with, makes it a little bit smaller. There's no other reason. And then I'm going to save it in 2 different formats. So someone was asking, how do we save it as a CSV? You can use the write CSV command with that data set. I updated this DAT subset, and put the file name, or I can save it at this RDS. If you're used to CSV, this is the easiest way. RDS is nice. It's a specific R data format. I have it here, R data serialization format. And it's nice because it retains all of the metadata. A CSV will just kind of turn it into a flat text file. It doesn't matter which one to work with, or we can save both of them. If you're working locally on your machine like I am, this is going to save it into your working directory. If you're working in the IPUMS, in the iGuide platform, it's going to save it right here to your working directory. And if you were not able to run this IPUMS data extraction notebook, there is a hosted version of this extraction of the final file that we're going to use for the next step. Okay, so we're doing on time. Okay, 15 more minutes. So we got to the end of our steps of where we did our data, specified a data extraction, did the data extraction, took a look at it, did a little bit of manipulation, and we saved it. So now we have that available, and we're going to move to our next notebook. So we're all set. All set. So our next notebook we're going to do is chapter 3.2. That's not true. We're going to do okay, that's 2 tabs. We're going to move on to 5.1. There we go. Data cleaning and prep with IPUMS USA. I'm going to run this. I'm going to run this here within the Jupyter hub in iGuide, since I think we should be able to run this. We don't actually need the IPUMS. IPUMS are package for this because we've already done the data extraction from IPUMS. All right, so what we're going to do here is we're going to use that IPUMS USA example file. We'll use the RDS version because that has all of the metadata that we attached to the previous, or sorry, that is attached to that data set. You can use this CSV as well. It's just not going to have some of the like labels and things. Can you show what file path object is? Where is that object actually saved? So are you talking about the file path object that's like the downloaded object? Where is it? The file path object is, I think, saved in the working directory that I'm working in. So I move this as my local working directory. It's not really usable outside of just being an object that you can then read into R. I think it's this one. No. Yeah, it's this object, HTML. I'm not sure. Yeah. So it's not really usable until you run the extraction process with the IPUMS or package commands. That's also something that I think even the IPUMS people can answer. How can we download data easily such to do the exercise? Are you asking how to download the, so working through this notebook will allow you to download that data directly into your notebook. There is a CPS data extraction notebook that I have that I'm going to release soon, but essentially it's the same workflow, except you would specify CPS in your microdata, and you would have to, when you're doing this metadata review, you would specify CPS here, and you can get all the CPS available notebooks and then do your selection. So it's essentially the same workflow, except you would specify CPS instead of USA. That's the advantage of running R. Eric has a great answer to that. Section 3 of the notebook. This? Yeah. Okay. If someone has more question about the file path objects, let me know. I think I answered that. You can just think of it as an object, that's the downloaded object, and then use R to extract your data from it. Okay. So again, we have kind of an overview of the setup available for this particular notebook. We're just going to use dplyr and Haven. Haven is going to help us create factor variables. So I'm going to load my packages. Yeah, so that is a really good question. And that I don't have really honestly an answer for it, because that would be more of an answer for the IPUMS developers. And the way that their backend is set up and the way that those data extractions happen. Yeah. But I also, a specific note on CSVs, as I mentioned, so CSVs also do not have metadata, so they don't have meta information on like factor levels or labels and things like that, variable level labels. So my guess is potentially part of the reason that there's those extra steps and there's kind of a more complicated data set or data object is to allow some of that metadata to be included in the download. But again, I don't have a super answer for you, but yeah, I do feel for you that it feels like it's a couple extra steps to do that extraction. But again, one of the nice things about R is that once you get it set up, it's really easy to just keep running that same chunk of code over and over again. And if you were to use the online portal, I believe the data download is, I don't think it's in CSV either. I can't remember. Okay, so we're in our next notebook. We're installing the two packages that we need. We're going to read in that IPUMS USA file. If you need to access that file and you're in the Jupyter hub within the iGuide platform, you can do it up here. There's kind of some links to get that file. If you've worked through the notebook, you should have it on your local machine, but you can also load it directly in on iGuide. Here is that file, and you just access data source, and that's going to put it right into your workspace, or you can download from my GitHub and import it into your workspace here. It's pretty easy. So if you weren't able to run through that notebook, that file is available for you on the platform. So the next thing we'll do is we're going to read that file Here you could read the CSV version. The hosted version is the RDS, but I'm using the RDS because, as I mentioned before, it has that metadata. We're going to read the RDS. Don't worry. Oops. Oh, no. Okay. Just going to upload that. So we're going to import that RDS file. We're going to look at the dimensions. It has 98,000 or 99,000 variables for 19 objects, so that's 99,000 individuals living in Michigan in 2010 during that 2010 ACS. It's not everybody in Michigan, it's a subsample that was used for that ACS survey. And here we're going to take a look at the columns for that data. Yes. Thank you, Rick. So we've got everything that we had, which is the exact same data as we had before in our previous step. So all this information on race, age, all the stuff that we downloaded, we're loading that same data set right back in. And here again is the review of kind of what columns are included in that data, just so information that we have that available to look at. So this particular step is going to be a little, or particular notebook is going to be a little bit of introduction to some cleaning and data management steps. This is kind of a lot of the steps that I use personally for my workflows when I'm cleaning new data sets, or when I'm exploring new data sets, or when I need to do some management. So I'm just going to take you through the steps of doing those. So first, the first thing I usually do is do a quick summary of the data. What I'm doing here, rather than just do summary dat, is I'm specifying a subset of the variables in the data set that I want to summarize. There's a lot of things here like sample identifier, serial number that I don't really care about for my analysis. I just am interested in these demographic variables. So I'm going to take a look and see what we've got. So we have sex. We have, looks like 1 and 2, levels 1 and 2, age, we've got 0 to 94. Everything is looking okay so far. So what I want to do in this initial summary step is just take a look and see if there's anything that kind of springs out at me as potential issues in my data, or potential things that I want to revisit while I'm doing my cleaning, and make sure that I have everything cleaned correctly. So a few things to notice: everything is coded in numeric, even though some of the variables are actually categorical. So this is a really important thing, and something that happens all the time with demographic data. You have something like race, which is clearly not numeric data, but it's just represented by numbers. So one of the reasons that it's really important to recode your numeric variables in the data cleaning steps is if you're going to use this variable, race variable, for example, in like a regression, you want the computer to know that those are categories and not numbers, because you don't want to interpret this as a number. You don't interpret like white as 1 and then black as 2, and that the difference between those two is not numerical. So we're going to recode some of our categorical variables. This particular data set does not have any missing variables. If there were missing variables, there would be a line under here that says NA and have a number of missing count. So we know that that's great. However, we want to be skeptical and look out for any codings that indicate missing, which we do potentially have here. The total income, which is this income variable, the maximum of this 9999. So it's possible that someone's income is that number, but what I think is more likely here is that there's a top coding variable that's 99999. And that's just an indicator of either a top coded variable, so it's like this is the max and up, or it's a missing variable, or it's not relevant for that particular individual. It's some sort of special coding. So when you see lots of 9s like this, often people use these kind of multiples of 9s to indicate missing or special coding. Or if you see any other kind of number like 9998 or something, just keep in mind that a lot of times these are tap codings or special codings, and you should take a look at your metadata before you do any analysis. So we're just going to keep that in mind. And we have one more thing. The smallest income total is negative. What does that mean? We don't need to have answers to these questions yet, but we're just taking a look at our data and see if there's anything that might be amiss that we want to take a look at and review and process. So the first thing we're going to do is we're going to take our categorical variables and we're going to clean them up and we're going to recode them. So as I mentioned, those categorical variables are coded as numeric, but it's not really appropriate to analyze them as numbers, right? We want to analyze them as categories. So these are our 3 categorical variables that we want to manage. Yes, I want. Yep. So we're going to use this function from the Haven package to create factor variables. So factor variables are kind of a ordered categorical variable or a categorical variable that when we code a variable as factor, the computer in R knows that that is categories and not numbers. All right, so this is a little supplement command or function that I created. This is not necessary for your analysis, but it makes this like nice little way to take a look at everything. So just a kind of like handy helper function. So it's called variable nice, and I'm going to say, okay, I want to look at the race variable from variable nice, and it's going to give me this nice little overview. So here's all of the levels of race. Here's the number of individuals in the data set that are that particular race. Here's the numeric code. So we know we're using numbers even though we have categories. And here's the percent of the whole sample that's that particular group. That's just an overview of that little function. We're going to come back to the race variable. So the first thing we're going to do though is recode the sex variable. I took a look at the codebook on IPUMS USA. So if you go to this IPUMS USA action variables, you can find all of the information or all the meta information descriptions of all the special codes and whatever for all the variables. And you can do a search, I think, within this, but I've given you links for this particular example just to make it easy. And I like to review the metadata in the codebook for all the variables just in case there's anything like this where there's special codes. As I mentioned earlier, and this was an example of it, we often use 9s or multiples of 9s to indicate missing or something like that. So we know in this variable there's this 9 code that would indicate missing. For this particular variable, in our data, we don't have any instances of missing, but it's good that we did a double check just to see and make sure that we know that there aren't any missing there. If we had missing, we would recode them as missing rather than have them as 9. But we don't need to do that for sex. So we're going to move on to race. Here's our nice overview again. We also have a supplementary race D, which is a race detailed variable that automatically downloaded with the race variable. We're going to take a look and note that it has a lot of categories, 243, and there's 104 of those 243 categories that are in our data set. So there's a lot of detailed race categories. So we have a combination of this simple race variable and this detailed race variable. I take a look at just the first 10 categories of the detailed race variable. You can see we have these 2 that are just the same as in our simple race variable, but then we have we're starting to see, this is just the first 10. We're starting to see some more details of particular Native American tribes. And there, if you look more deeply in the rest of this, you'll see that there's also specific Asian ethnicities and other things that give you more detail about an individual's race for certain people. So we're just taking a look and seeing that we have that information. So what we're going to do for this particular exercise is I'm going to make a new variable that kind of combines both some information from race as well as the detailed race variable.
And Kate, I'm going to jump in just for a second. We have 1 minute until the top of the hour. So just in case if people need to hop off, we would very much like to thank everyone for attending. Kate can finish this example. We've been answering questions in the chat. I will repost links just for everyone in case if you don't have them on how to reach out to Kate through her webpage if you have further questions. We can take a few more questions at the top of the hour as well. So sorry to interrupt. I just wanted to make sure in case if people have to hop to a next meeting that we're just saying thank you.
Yeah, thanks, Eric. Yeah, because I was just thinking that I know I was running out of time. What I'm going to do is just going to quickly wrap up this particular race example, and then I'll leave you to explore the notebooks on your own, and I'll do a little bit of wrapping up. But for this exercise, I use a combination of the mutate function from dplyr as well as this case one recode function to specify exactly the way that I want to recode these two variables or this variable. So what I'm going to do is I'm going to say we're going to make a new variable race recode. And whenever the variable race is one, it's going to be 1 for the new variable, 2, 3. And then I'm going to make this combined variable for these these 3 Asian categories. So that's going to include 4, 5, and 6 for the new level 4. I'm going to make the old level 7, which is other race, into a new level 5, and then 8 and 9 going to go into 6, and 8 and 9 are 2 major races or 3 races. So I'm just making a simpler version of the race variable. I like to do this both to kind of maybe tailor a variable to what I'm specifically interested in using it for my analysis. And also, especially I have 5 situations where I have very small numbers, like for example, in this other race category or these Asian race categories, which are very rare in my data set. I might combine them just to give myself more statistical power if I'm doing an analysis. So it's a little easier to use larger categories. Obviously, sometimes you want to use more detailed categories, and maybe you want to use the race detailed variable instead. It depends on your analysis, but I'm just giving an example of how you can recode. And then what we're going to do is use the mutate function again with this factor function from the Haven package to label all of our variables. So this is where we get that factorization step where we're turning a numeric variable into a categorical variable that has labels. And now if we use it, R is going to know that it's categories and not numbers. So just the levels in order and then our labels in order. And after we do that, got to run this one, run that one. And after we did that, I'm going to take a look at it again. And now we see this kind of combined where we have all the Asian combined into one group. And we have the 2 or more, or the 2 races and the 3 or more races combined together into a new 2 or more races category. So just a little reorganization. Okay, so I will wrap up. I know we're over time. If you have any questions, let me know. You can also email me if you take a look at that link tree. I don't know where. Okay, link tree again. It has hopefully a lot of the links you need if you're interested in following my newsletter or taking a look at the website. It also has my email there if you want to email me. I'm happy to take questions over email. And I want to say a special thank you to Eric has been doing a fantastic job. Thank you again for being in the chat. It allows me to actually focus on doing the demos. So I really appreciate Eric being here. Diana, I miss putting you in the special thanks, but of course, always Diana, I'm so thankful that you're around, and then everyone else who has helped me out administratively or the details of these projects has been fantastic. So yeah, if there's any additional questions, please let me know. And otherwise, that is it for now. Please stay tuned. Yeah, you can run this notebook in your, sorry. Yeah.
Oh, no, go ahead.
Yeah, Jacob, you can run this notebook in your Google machine. Yes, you can download the notebooks through my GitHub if you would like.
Yep. Just
Sorry,
thank you
Eric.
again, everyone. In the chat, I posted help at i-guide.io. If anybody's running into issues logging in, trying to run the notebooks, please email that address. The support team can help you connect. Make sure that you're able to log in and everything else. The link tree also has Kate's information on it. So feel free, and then I just reposted a link directly to the notebooks page on GitHub. So feel free to reach out, including emailing the iGuide page asking how to connect with Kate, and we can get everyone connected to get your answers. Get answers to your questions. But thank you, everyone. Have a wonderful rest of your day. And a reminder that there'll be another webinar covering more of the R Spatial Notebooks coming up. Please sign up for the mailing lists. I added links in the chat for more info there. And then we will hopefully see you all in the next webinar. Thank you, everyone.
Thank you.
Thanks, Kate.
And I
Thanks.
saw, thank you. Yeah. And I just want to add, I know that Anad, thank you so much. Not enough thank yous to Anad, Eric, and Noah. I know that you guys have been helping me with the back end stuff and on the fly as well. Thank you. And one last question. Yeah. Can you adopt it for your research? Please do. That was the reason that I created these. So please take them and like modify them for your own use.
Thank you.
Thank you so much.